Okay, don't forget, next week, Tuesday, is the AMC 12. You report to the lower gym at 7:30. Okay, who didn't get practice problem? Chen and Pan. We'll do some of these during extended, because it counts as a quiz. Okay, no questions on this night's homework. Oh, you guys are good. Okay, well, what did you guys discover about this matrix here? What did we discover about it? It doesn't matter if it's 2 by 2 or 3 by 3, right? What did we discover? It acts like the number 1. When you multiply any matrix by this, don't you get itself? So it acts like the number 1. It's not the number 1 though. We call this the identity matrix. I'll call it I. Now in the homework, one of them I called J, yeah, because I just didn't want to confuse you. But officially, we call this the identity matrix because it's the multiplicative identity. It acts like the number 1. So to get the identity matrix, you have 1s in the main diagonal. The main diagonal starts from the upper left to the lower right, and 0s everywhere else. That's called the identity matrix. And this is one of the few times where the commutative property of multiplication holds, right? A times I equals I times A. And they both equal to A. So when you multiply any matrix by this, you just get itself, and it doesn't matter which order. So, well, if you look in your notes, this is in your notes, right? That's kind of important. Okay? See, like number 6, you have to do A times I, then number 7, you have to do I times A, right? And they come up to the same thing. That's the kind of things you gotta discover. And everybody can do 12 and 13, because that's probably gonna be on the quiz. You sure? Now is the time to ask. You're on a bomb now, you gotta climb, some of you gotta climb out of a deep hole. Yeah. How hard is it to write a number on the board? Okay, which one you want to do, 12 or 13? They're both the same, it's a different way.
13.
Okay, 13. Okay, so x, now we don't know what x times e equals e. It says solve for matrix x. Can I just do this? Divide both sides by e, d over e. No, if you do this, this is a triple fatal error. There's no such thing as division in matrices. You cannot divide. Like you watch, some of you on Friday are going to divide. Triple fatal, minus 12 right there. Okay, so we don't know what matrix x is, but we do know that matrix E is, what is it? Where is it? 3, 4, 1, 2. And we know that matrix D is 2, 3, 5, 7. So what dimensions does matrix X have to be? If you're going to multiply it by a 2 by 2 and you get a 2 by 2 as your answer, it's got to be 2 by 2. And those of you who are out there, did you guys watch the video? Okay, 10? Oh, you're going to be way behind now. Okay, now we don't know what it is, so we just put letters in it. A, B, C, D. Now, of course, there is another way to do it, but we haven't learned that yet. So this is the way you got to do it right now. Okay, so yesterday we learned how to multiply matrices. Okay, so if you multiply a 2 by 2, this is for those of you who are absent by a 2 by 2. The only way you can multiply them is this and this number got to be the same, and they are. And the resulting matrix is going to be 2 by 2. If you look at the two outside numbers. So to get this element here, which is in the first row and the first column, you go across the first row and you come down the first column. The one on the left, you always go across the rows. The one on the right, you always come down the columns. So if you go across the row and come down the column, you multiply 3a plus b, like that. Okay, here, you go across the first row, now you come down the second column. So that's 4a plus 2b. This one over here, you go across the first row, second row, come down the first column, 3c plus d. Yeah, multiply, you gotta practice. That's why this whole sheet is just practicing multiplying. And then finally, this one here, go across the second row, come down the second column, 4c plus 2d. And that has to equal to this, 2, 3, 5, 7. And the only way the two matrices can be equal is what? The corresponding elements got to be equal. So in other words, this got to equal 2, that's got to equal 3, this got to equal 5, and that's got to equal 7. So 3a plus b equals 2, 4a plus 2b equals 3, 3c plus d equals 5, and 4c plus 2d equals 7. And then you just solve these equations. So like, if you look at these, look, that's just 2 equations, 2 variables. And that's another 2 equations, 2 variables, and you just solve them. So that's how you do problems 12. I'm not going to do the solving, that's just algebra 1. Yeah. You guys got to practice that. Some of you still have difficulties. When you come out of algebra 2, you're supposed to be experts at 3 equations, 3 variables. When you come out of pre-calculus, especially this chapter, you should be experts at solving n equations and n variables. That's what we're gonna, in fact, that's probably one of the most important things you're gonna learn this whole year in this chapter. What if you go to college and you gotta solve 20 equations, 20 variables, what are you gonna do? Take like your paper and pencil and start working quickly. No! You do matrices on your calculator. So what's gonna happen during extended is we're gonna go over the homework, then I'm gonna show you how to use your calculator with matrices. And then, so make sure you bring your calculator tomorrow, and then whatever time left, we'll do AMC problems. Okay, so does that answer everything?
Yeah.
Okay, finally somebody talk in this class. Okay, now what are we learning today? We gotta learn how to do matrix algebra. We gotta be able to find the inverse of a matrix. In fact, let me see. Oh, last night you actually found the inverse of a matrix in number 12, and you just didn't realize it. Okay, here we go. Okay, first of all, matrix algebra. Now remember, the most important thing about matrices, the commutative property of multiplication does not hold. A times B is not equal to B times A. We already saw one case today where that works, right? And what is it again? A times I, when you use the identity. A times I equals I times A. That's one of the few times when the commutative property of multiplication works. Now, there's one other, which we're going to learn soon. Okay, so let's start off easy. AX equal B now. These are not numbers now, these are matrices. How do you solve for matrix X? This is like going back to pre-algebra, right? Pre-algebra. What was the easiest equations you learned to solve? 3x equal 4, right? How do you solve for x? Divide both sides by 3, right? That was the beginning of algebra. Okay, but now we're going to do matrix algebra. You have certain rules. Like right here, is it legal to divide both sides by 3? Yes, because these are numbers. But in this problem, can I divide both sides by 8? No, because there's no such thing as division. So then what do? You multiply by the inverse. Now, what the heck is the inverse of a matrix? Well, actually, you found it on last night's homework. An inverse is a matrix such that if you multiply it, this is what we denote as the inverse. If you multiply a matrix times its inverse, or the other way around, see, this is the other time when the commutative property works. What are you going to get? You're going to get I. Just like, okay, somebody going, what? Go back to 7th grade math, or even 6th grade. What is the multiplicative inverse of the number 3? No, yeah, it's 1/3. That's because when you multiply them together, you get 1. We call this the multiplicative inverse of that. You guys probably know it as its more common name, the reciprocal, yeah? But the official name is the multiplicative inverse. So, does every single number have a multiplicative inverse? You're afraid to take a stand? Okay, what about 4/5? What do I need to multiply that by to get 1? 5/4. So this is the multiplicative inverse of that. So true or false? Every number has a multiplicative inverse. False. What about 0? What do I multiply 0 by to get 1? Oh, 1/0 because the zeros cancel. No! 1/0 is undefined. Every non-zero number has a multiplicative inverse. See how it's 1? See, I acts like the number 1, but it is not 1. Now, on Friday's quiz, some of you are going to write 1. I know already, because it happens every year. But there's no such thing as the 1 matrix now. There's no such thing. And then every year, you know what students say? That's how I write my I. And I'm sorry. You need to write your I like that. I'm telling you right now, because every year it happens. I've been teaching this for 26 years. It happens every single year. And even though I'm telling you ahead of time, there's going to be 3 or 4 of you still going to write 1. There is no such thing as the 1 matrix. It's called I, the identity. Okay, so here we go. How can I just isolate X all by itself? Well, before we go any further, what else did we learn last night somewhere? What about when you're multiplying 3 matrices together, like this? Can I group them like that and group them like that? In other words, is the associative property of multiplication both? Yeah. Yes. In fact, it's in the notes, I think, right? The associative property works, but the commutative property doesn't. So as long as you keep them in the same order, it doesn't matter which ones you group first. You know what I'm talking about? As long as you don't change the order, you're okay. Okay, well, so what can I do to get rid of this A so I can just have X? You multiply both sides by A inverse. But you have to do it on the left. How come I can't? Why? So if you multiply A inverse on the left on this side, you have to multiply by A inverse on the left on that side. Why? Because the commutative property doesn't work. Like when you have see, like over here. If you have, okay, what if you have this? 3x equal 4. Can I just multiply both sides by 4/3 like this? Wait, that's dumb. Why am I multiplying both 4/3? Can I just multiply both sides by 1/3 like that? Yes! That's because when you work with numbers, the commutative property works, right? 2 times 3 equals 3 times 2, right? But with matrices, A times B is not equal to B times A. So if you multiply by something on the left here, you got to make sure you multiply it on the left on the right. You get it? So if you multiply on the right on the left, you got to multiply by right on the right. Okay, now, when you multiply 3 matrices, it doesn't matter what order you do it in. So if I do it this way, what is any matrix that's inverse times itself? You get I. Don't write 1. Okay, and then what is I times any matrix? Yeah, it's just that, because that acts like the number 1, but it is not the number 1. And there you go, that's how you solve for X. No. I'm just showing you all the steps so you understand how it works. But hopefully, when you do your homework tonight, you just look at that and you go straight to that. You just go, oh, to get rid of this A, you got to multiply by A inverse on the left. So that's what you do. Okay, let's go to the next level. AX plus B is equal to C. I changed my mind. I'm going to say XA. Solve for matrix X. Okay, well, is this legal? Can I subtract B from both sides? Yes, because there is such thing as subtraction, right? How do I get rid of this A here? You multiply by A inverse on the right, because you have to have the A inverse next to the A. It can't be like on this side. It has to be next to it. So you have to multiply by A inverse on the right, so X equals C minus B, A inverse. It has, since you're multiplying on the right here, you have to multiply on the right there. Get it? If it's on the left, you got to do it on the left. If it's on the right, you got to do it on the right. So if you don't put it on the correct side, that's going to be pretty much a fatal error, because there's no such, the commutative property of multiplication doesn't work. Okay, kick it up a notch. How about AX plus BX? No! AX plus C equals BX plus D. These are all matrices now. These are not numbers. How do I solve for X? Put all the X's on one side, put everything else on the other, right? So AX minus BX equals D minus C. Okay, can I factor out the X? Yeah, you can factor it, but notice that they're both on the right. So if you're going to factor out the X, you have to factor it out on the right. You guys get that? You cannot factor it out on the left because the X is on the right. Okay, and And then to get rid of this, what do? Divide both sides by A minus B. No! There's no such thing as division. You multiply by A minus B inverse on which side? The left. A minus B inverse times D minus C. Boom, there you go. That's how you do matrix algebra. So, okay, anyway, so right there, first three problems, you just gotta do matrix algebra. It's easy. Okay, next problem, you have to be able to find the inverse of a 2 by 2 matrix. Now, did you even do it? Let's see, D. You actually did it on last night's homework. Okay, so what if I give you a matrix? Okay, I'm not going to make it the same as last night's homework. How about 3, 4, 5, 6? Okay, that's a good one. Find the inverse of this matrix. How do you do it? What is, okay, find A inverse. Well, what is an inverse? If this is matrix A, which is 3, 4, 5, 6, and I'm trying to find an inverse, I don't know what it is. So if this is matrix A, if this is A inverse, if I multiply any matrix by its inverse, what am I going to get? I. Not 1 now, I. So if I don't know what A inverse is, what do I do? Like last night's 13 and 14 on last night's homework? A, B, C, D. We just call this the ABCD method. Okay, and then you just do what you did on last night's homework. So multiply these two. So if you go across and come down, 3A plus 4C. See, that's what I told you. If you don't know how to multiply, you're going to fail this chapter, which is the easiest of the four. You gotta learn how to multiply. That's what you gotta do last night's homework. Go across and come down. 3B plus 4D. 5A plus 6C. 5B plus 6D. And that's gotta equal 1, 0, 0, 1. So therefore, this gotta equal 1, this gotta equal that, this gotta equal that, this gotta equal that. 3A plus 4C equal 1. 3B plus 4D equals 0. 5A plus 6C equals 0. 5B plus 6D equal 1. And then you just solve those equations. Takes kind of long. Well, just imagine, look at the number 5 of tonight's homework. You have to solve 9 equations, 9 variables. Here, what if I gave you, this is only 2 by 2, people. If it's 3 by 3, okay, what if I said, okay, matrix A is, I need more room. Let's just finish this problem first. You want me to solve it? Should I solve it? You guys can solve these, right? So anyway, how long would it take you to solve these 2 equations, 2 variables here, and then these 2 equations, 2 variables there, and then write it in the matrix? Well, if you took algebra 1, 2 minutes at the most, right? Yes. That's too long, Mr. Park. There's got to be a shorter way. Yes, but if you don't know anything, then this is the only way you know how to do it, right? But fortunately for you, there's a theorem, if you look in your notes. The theorem states that if matrix A, and this is only good for 2 by 2 matrices, A, B, C, D, then A inverse is equal to 1 over AD minus BC times, you switch these two, so in the main diagonal you switch them, and then in the other diagonal you negate them. Woo! That's a theorem, but it only works on a 2 by 2 matrix, huh? Oh, so then can I do that for problem number 2 on tonight's homework? Yes! That's why I'm teaching it to you. So, if this is matrix, okay, so here, if this is matrix A, to find A inverse, all you gotta do is use this theorem instead of doing this ABCD nonsense. 1 over, okay, what does it say? AD, so that's this times this, minus that times that. Hey, that's something we learned last year, Mr. Park. Remember when you have a 2 by 2 matrix, what is this times this minus that times that? That's called the determinant, right? Remember, Kramer's rule? You guys all said you did Kramer's rule last year, right? So that's what this is, although I haven't even mentioned the word determinant, although I did say it. So what is this times this? 18 minus that times that, 20. 18 minus 20. Negative 2. And then you switch these two, and then you negate those two, And then you can leave it like that, or you can put the negative half in, because remember, when you multiply by a constant, you gotta multiply everything by the constant. So you could go negative 3, 2, 5 halves, negative 3 halves. That is the inverse. Isn't that way faster? Yeah, that's way faster than solving these 4 equations for variables. But like I said, if you don't know the theorem, that's the only way you can do it. So does everybody get the theorem now? Now that only works for 2 by 2. So look at number 5 on tonight's homework. What happens if I give you a 3 by 3? So let's say matrix A, 3 by 3. 2, 3, 5, 4, 1, 2, 3, 2, 1. Let me just make up something. How do I find the inverse of this? What do I do? Well, if this is matrix A, if I multiply it by its inverse, what are you going to get? I, the identity matrix, which acts like the number 1. So this is what you got to do. Well, if this is 3 by 3, and that's 3 by 3, this got to be 3 by 3, so. Can you see what you got to do? You got to solve 9 equations, 9 variables. Some of you are going, what? I better not see this on the board tomorrow. Okay, so how do you multiply this? You go across the first row, you come down the column. 2a plus 3b plus 5g. We need more space, Scotty. Okay, then over here, you go and come down. 2b plus 3e plus 5h. Again, 2c plus 3f plus 5i. Okay, then this one, you go across, come down. 4a plus d plus 2g. 4b plus e plus 2h. Woo! 4c plus f plus 2i. Okay, then finally across come down. 3a plus 2d plus g. 3b plus 2e plus h. 3c plus 2f plus I. And that's got to equal to the identity matrix. Which means this got to equal 1, this got to equal 0, this got to equal 0, this got to equal 0, that's 1, that's 0, that's 0, that's 0, that's 1. And then you solve them. But then, since you came out of Algebra 2, you should be experts at solving 3 equations, 3 variables. Because that's what that is, right? Right here you have 3 equations, 3 variables, 3 equations, 3 variables, 3 equations, 3 variables, and you solve them. So you just have 3 sets. You guys look dumbfounded. But right now, that's the only way we know how to do it. Is there a shorter way, Mr. Park? Yes, but we got to learn a lot more stuff before I can even teach you that shortcut. Okay, and then the last thing for today. Okay, look at number 4. Now, this is probably, like I said, this is the most important thing I'm going to teach you probably. One of the most, like if you just had to put 10 things in a bag, this thing right here, like when you go to college, this is probably one of the things you put in the bag. What happens when you have a system of linear equations? Like, okay, let's 2 equations, 2 variables. 2x plus 3y equals something. 4x plus 5y equals something. And I want to make the answer come out nice. Okay, there. 2 equations, 2 variables. Now, how would you solve this? You'd use Algebra 1, right? Now, in real life situations, if you're given 2 equations, 2 variables, you do not use the method I'm going to teach you now, okay? Even 3 equations, 3 variables, you don't. However, once you get up to 4 equations, 4 variables, then, or like I said, 100 equations, 100 variables, you don't want to use algebra. You want to use matrices, okay? So, watch what I'm going to do. First step, I'm going to call matrix A 2, 3, 4, 5. Where did these numbers come from? There's the coefficients of the variables. I'm going to call matrix X, XY, and I'm going to call matrix B 7, 13. Therefore, A times X equals B is the representation of this. You guys see that? I don't know what you're talking about. Okay, I'm just going to show you that. What is A? this. What is x? So what happens when you multiply this times this? A times x. What is this times this? How do you multiply? You go across the row, you come down the column. So what do you get? 2x plus 3y. And then go across and come down. 4x plus 5y. And that's got to equal to b. So doesn't that mean this equals 7 and that equals 13? Isn't that what this is right here? So this is just the matrix representation of this system here. Okay? See, but if you don't know how to multiply, you can't do anything, yeah? So, how do you solve for matrix x now? You multiply by A inverse on the left. There you go. And when you solve for matrix x, that's just x and y. That's the solution to the system. And do we know how to do that? Did I teach you how to find an inverse of a matrix? Yes, I just taught you that theorem. So 1 over, this is matrix A here. This times this minus that times that. 10 minus 12. 10 minus 12. If you cannot handle single digit numbers, what prayer do you have this chapter? Negative 2. And then what do? What do I do with these two? You switch the 2 in the main diagonal, and you negate the ones in the other diagonal. And then you multiply that by b, which is 7, 13. There you go. That's the solution to your system. Except we got to simplify. Now, what do you want to do? You want to put the negative half in here, or you want to put it in here, or you want to multiply these two first and then put it in? Think. Let's have foresight. Put the negative half in. No. Why should we save it for later? Because you put it in, you're going to introduce fractions, and some of you just, once you put fractions in, it's all over but the crying, right? Okay, so this is a 2 by 2 matrix. This is 2 by 1. Can I multiply them? Yes, because those are the same, and the result is going to be 2 by 1. Okay, so go across and come down. We got 35 minus 39. 35 minus 39. Negative 4. Go across, come down. Negative 28 plus 26. Okay, you have to write it out. Negative 28 plus 26. Oh, now I can do it. Negative 2. Now put the negative half in, and you get 2, 1. That's the solution to this system. That means these two lines intersect at the point 2, 1. Mr. Park, that's a lot of work. Yeah, in real life, you don't do this for 2 equations, 2 variables. In real life, you don't. Yeah, you just use algebra 1. However, tonight's homework, you got to do it this way because I'm trying to lead up to something. Okay? Oh, so wait, Mr. Park. So if you gave me 3 equations, 3 variables, you do the same thing, but the problem is right here. In order to use this method, you have to be able to find the inverse of a matrix. 2 by 2, I gave you a theorem for that, right? Well, what about 3 by 3? Isn't it kind of hard to find the inverse of a 3 by 3? You got to solve 9 equations, 9 variables. What if you, okay, so what if you had like 10 equations, 10 variables? How do you find the inverse of a 10 by 10 matrix? You got to solve 100 equations, 100 variables. But see, that's the thing. Your calculator can do that like that. So that's what we're going to learn during Extended. How do you work with matrices on your calculator? And then I also looked it up, on some of your iPads. Did you guys download the Pocket Cast? Yeah, so the free version doesn't have all the matrix stuff. So if you want all the matrix stuff, then you gotta buy the premium version. But I wouldn't. Just use your graphic calculator. It's fast. Okay, so tonight's homework with all of the theorems I gave you, easy. Okay, now tomorrow we gotta learn determinants, I think. Let me see. Yes. No. Yes. So let me get this straight. Last year, Mr. Takayesu's students, you guys only learned how to find the determinant of a 2 by 2 matrix. I like 2, 3, 4, 5. But Mr. Rubash's students, you guys learned how to find determinants of 3 by 3, like 3, 2, 1, 2, 4, 3, 1, 2, 2, like that. 3 by 3. Like. Okay, but see, in this class, we got to do 4 by 4 and higher. Do you guys even remember how to do this? Who's in Mr. Rubash's class? How did you guys do it? Diagonals? That's the baby way. Okay, it doesn't matter, because tomorrow I'm going to teach you like you don't know anything. Okay, we're done then. So you have 9 minutes left. And again, I'm going to repeat, this is the easiest chapter of the quarter. But you guys gotta learn how to multiply first, because if you can't multiply, you're gonna fail. It's the easiest chapter. You gotta practice the multiply. Because almost every single problem on the test, you're gonna be multiplying. And since it's only arithmetic, it's pretty much all or nothing. So if you just make one arithmetic error, -8. That's why you gotta practice to get good. So if you didn't get good at arithmetic in elementary school, you'll get good at it now.